All right, so now we're going to talk about a concept called data that is skewed, okay? And we're also going to look at and introduce a graphical data representation called a histogram, okay? So we've got a data set here, and it looks pretty organized, and it is. In fact, what we're going to see in just a couple minutes, that this data is actually symmetrical, or it has symmetry. And this is something that we like about data. We like it when our data set is symmetrical. There are a lot of great advantages in drawing conclusions scientifically when our data set is symmetrical. So let's use Minitab to find out what is the mean of this data set and what is the median of this data set. All right, so I've logged into Minitab and I'm selecting blank project. I'm now going to start entering the data. All right, so now I'm going to go up to Stat, Basic Statistics, Display Descriptive Statistics, and although I don't need it, I just want to practice. I'm going to go to my Statistics button. I'm going to hit Variance and Range, even though I don't need them for this, and I'm going to hit OK. I accidentally put a data value in C6, so that's why it's showing C6 here. It was just an accident, but my data's set is in C1, so I'm going to hit select and then I'm going to hit OK. And let's see what we have here. The mean is 6 and the median is also 6, and that's what I expected to happen. Okay, and so X bar is 6 and the median of the data set is 6. Okay, now here's the interesting thing. This is evidence that our data set is symmetrical. Okay, so when our data set is symmetrical, the mean is equal to the median. Okay, so let's go ahead and say that. All right, and I changed the symbol here to approximately equal to because we rarely ever in a large data set have a mean that is exactly equal to the median, but it's approximately equal to. And in this case, it is exactly equal to, but it's also a very small data set that I contrived. Okay, but when a data set has symmetry, the mean of the data set is approximately equal to the median of the data set. Okay, now we can look at what is called a histogram. And a histogram is a graph of the data points. That's a rough definition of what a histogram is. It's a graph of the data points. Now I should clarify, a histogram is just one of many graphs of data points. So this is one of the many different kinds of graphs of the data points, and it's one that is very useful for identifying and symmetry and also for identifying skewed data. Okay, and so let's see how we can identify or create a histogram here. What we would do here if we want to see a histogram of this data is we would go to Graph, then we would select Histogram, we would select Simple, whoops, and then OK, and then we're going to select our data set, or our column. In this case it's C1. Then we're going to hit select, and now we hit OK, and this is our histogram. And look, what does symmetry mean? Symmetry means a mirror image on the left and the right, okay? And that's what we have here. If we were to draw a vertical line straight down the middle here, doesn't this look basically, it looks identical on the left as it is on the right. This visual graph has symmetry. The left side is a mirror image of the right side, and so we can see the symmetry on this histogram. And this is one of the great uses of a histogram when doing research, when investigating and looking at the quality of a data set, is the histogram can show us whether the data set is symmetrical or if it's skewed, okay? And so what we're now going to look at is we're going to look at what skewed data look like. All right, so now we're going to look at a concept called skewed left. So this data set right here is skewed left, and we're going to see what we can understand about a data set that is skewed left. So the first thing we're going to do is we're going to go ahead and enter all this data into Minitab. All right, so we're going to open up Minitab and we're going to click blank project. And now we're going to enter all the data. Okay, and now we're going to identify the mean and the median. So we'll go to Stat, we'll go to Basic Statistics, Display Descriptive Statistics. We're not going to need the variance or the range, so we don't have to go in here and add and check those. So we'll hit Select here, and then we'll hit OK. And look, it tells us our mean is 5.14. What is that? Let me zoom in here a little bit. 5.143, and our median is 5.5. All right, so 5.143 and 5.5. Now, look what's happened here. Our mean and our median, they are not equal. They are not even approximately equal, okay? And so basically, let me explain what skewed left means. Skewed left is, okay, so if this is an x-axis and our data, oftentimes it takes on a curved shape, like a bell-shaped curve, okay? And we'll talk about that another time. What you're looking at here is symmetrical. It's approximately the same on the left as it is on the right, okay? But skewed left takes on a shape that looks kind of like this. It's sort of hilly here, and then it's steep over here, and then it kind of curves like that. And it's not bell-shaped. This is called skewed left, okay? And what happens is this with skewed left is the mean will be somewhere over here, but the median will be somewhere over here. And so the median of the data is going to be a larger number than the mean of the data. And so with skewed left, the mean is less than the median of the data set, okay? So anytime you run descriptive statistics, if your mean is smaller than your median, then you can say that the data set is skewed left. And we can see this if we were to look at the histogram. So let's go in here, we'll go Graph, Histogram, and we'll select Simple, OK, and we'll select C1 and select OK. And look at this, it's got that shape where it's sort of flat, it sort of slopes gently on the left, and then near the right side it peaks and then it comes down sharply. So this is this is skewed to the left, okay? And the mean is going to be somewhere over here, like it is. It's very close to 5. So this line right here between 4 and 5 is 5, okay? And then 5.5 is the median. The median is right here, and the mean is over here. So the mean is smaller than the median, so this data set is skewed left. Now let's look at skewed right. All right, so this data set right here is skewed right, okay? And we'll be able to see some qualities of skewed right if we identify the mean and the median of this data set. So let's go ahead and put this into Minitab. I'm going to select blank project, and I'm going to enter all the data in column C1 again. Now I'm going to go to Stat, Basic Statistics, Display Descriptive Statistics. Again, we don't need the variance or the range, so we're not going to add them. Hit Select, and then we're going to hit OK. We're going to zoom in just a little bit, and you can see here the mean is 3.857, and the median is 3.5. So the mean this time is larger than the median, 3.857. So 3.857, and the median is 3.5, okay? And so this is a quality of skewed right, when the median is less than the mean, okay? And so what we'll have here is, let me draw sort of another diagram of it. This time, the steep part and the peak are on over here to the left, and the skew, the slopey skew, points over to the right. So this is skewed right, okay? And so in this situation, we'll have the mean will be over to the right, and the median will be closer to the left, okay? So, this is 0 down here, and this is, like maybe 100 up here, okay? And so the mean is larger than the median, or the median is smaller than the mean. When that happens, the data set is skewed right, okay? Let's go ahead and look at that histogram. So we're going to go to Graphs, Histograms, select Simple, OK. We're going to select C1, select, and then OK. And look at this. We have the exact opposite of what we saw with skewed left. We have our steep part and our peak kind of over on the left, and then our slopey skew is over here on the right side. And we find our mean is, let's see, what was our mean? 3.857. So our mean is somewhere around here, but our median is, actually this, I guess, is 3.5. So this would be 3.857, and then this would be 3.5. And so the median is smaller than the mean, okay? And so the last thing that I want to say is I want to make mention of the kinds of data points that can create skewed data, okay? There's a concept called an extreme outlier. Sometimes we just call it an outlier, but an outlier can be, you can have an outlier, but it's still close to all the numbers. But an extreme outlier is an outlier that's very far away than most of the other numbers in the data points, okay? So an extreme outlier is an unusually large or small data point compared to most of the numbers. And so when a data set has one or more extreme outliers, it can have a very strong effect on the mean of the data set and also the standard deviation. However, the good news is the median actually isn't greatly affected if it's only one extreme outlier. That's all we have for symmetry and skewed data.